Okay, so to find the inverse function if you have a parabola, so say we have y equals x squared for example, this will not have an inverse because it does not pass the horizontal line test. So you need to actually restrict the domain so that it will have an inverse. So what we're going to do is we're going to restrict the domain so x is less than or equal to 0. So we're looking at this curve for x is less than or equal to 0, and the range would be y is greater or equal to 0. So to get the actual inverse, you swap the x's and the y's and you solve for y. But because I only took the negative half of the branch, then that would be my inverse function. Then the domain and range will be the same as the other one, they just swap. So the domain will be y is greater or equal to 0, so it'll be x, because that one goes there, and this one will be y is less than or equal to 0. Okay, so you could also get that from the actual equation. You can see that x can't be negative, so x must be greater than or equal to 0, and also the y is equal to a negative square root, that's why y is less than or equal to 0. If I actually drew this inverse, the other one's going like that, and so if you draw the line y equals x, it's just a reflection of that line in the x-axis. So it's y equals minus root x, which is that one. Okay. Alright, so we're going to look at where you have to complete the square to actually find the inverse, and we are going to restrict the domain. So looking at this question here, first of all, if you sketched it, you've got x minus 6x plus 2, x is 6 and minus 2. So if you sketch that, you have minus 2, 4, 5, 6. So it's a positive parabola, so it looks like that, and that would be minus 12, because when x equals 0, y is 0 squared minus 4 times 0 minus 12, which is minus 12. So at the moment it does not have an inverse. If you go halfway between plus 6 and minus 2, you get 4, and then divided by 2, halfway would be 2. So at x equals 2, that's where your vertex would be. You could also go minus b on 2a. So minus b would be minus minus 4 on 2 times 1. So it's 4 on 2, so see how it's x equals 2. Okay, so if we restrict the domain so that x is less than or equal to 2, then let's just do the range of that at 2. Like if we put x is 2, y is 2 squared minus 4 times 2 minus 12. 4 minus 8 minus 12. 4 minus 20 is minus 16. So that means that point there is 2 minus 16. So the range would be y is greater or equal to minus 16. So if we restrict that domain to that, then if we then need to find the actual equation of the inverse function, you start off with this. You bring the 12 over, and then out of this part here you actually want to create a perfect square. So to create a perfect square, you take the 4 and you halve it, square it, and add it. So you add it to both sides. So half 4 is 2, square it is 4. So you add it to both sides, plus 4 plus 4. So now you've ended up with y plus 16 equals x minus 2 all squared, because that's a perfect square. Y plus 16 is x minus 2 squared. Now, I haven't swapped the x's and the y's, so I'm just going to do that. You can do it at any stage, could have done it a bit earlier if you wanted to. Okay, and then to get rid of the square there, you square root the other side and you put plus or minus. But because we restrict the domain to the negative half of that graph, then y would be 2 minus, you bring the 2 over the other side, x plus 16. So you take the negative one of this. To actually sketch this inverse, the best way to sketch an inverse is to draw the line y equals x, looks like that. Find the point on your curve so that it got 2 minus 16 and swap it. So it's minus 16, 2. Because you went all the way out to minus 16, and then you went to 2, so somewhere there. It's got to go through minus 12. Now, one of the most important points that it goes through is this one here. Because f of x and f of minus x, they intersect on the line y equals x. So we know that if we drew this, we know that it actually has to intersect on that line y equals x. And that would be your sketch then of f of minus 1 of x. And you notice that it is just reflected in the line y equals x. It's got symmetry. So now to find the point of intersection of these two curves, because we know that they intersect on the line y equals x, the easiest thing is to find the point of intersection of y equals x with this one, and then we know it'll also lie on the other one, because then you don't have to deal with square roots and it's quite simple to solve. X squared minus 4x minus 12 equals x, because they both have the same y value at their point of intersection. X squared minus 4x, bring the x over, minus x minus 12 is 0. X squared minus 5x minus 12 is 0. So all that's left to do now, that we know that they intersect on the line y equals x, so all that's left to do now is use the quadratic formula. So it's minus minus 5 plus or minus the square root of 25 minus 4 times 1 times minus 12 over 2 times 1. So x is 5 plus or minus, so we know we take the minus root, so 25, and that'll be plus 48. So 5 and 8 is 13, that'll be 73. It'll be the negative, and the y value will be exactly the same because they intersect on the line y equals x, so the x value equals the y value, and that will give you your point of intersection. If you actually want to find the gradient of the inverse function at a point, sometimes it's easier to start with the original curve, which was that, f of x. So let's just say also this was at x equals, and we'll do up, let's just say it was at x equals 0, and that's x equals 0 on the inverse function, not the original. So you find dy and dx, which is simply 2x minus 4. If you swap the x's and the y's, you will have the gradient of the inverse function, but it'll be in terms of y. And then you flip it, okay? So you swap x and y. So sometimes it's easier to find the inverse of that than it would be to find 2 minus root, I'm pretty sure it's x squared plus 16. You could find the derivative of that if you wanted as well, it would still work. Just checking, it is, 2 minus root x plus 16. So it's not x squared, right, just x plus 16. Plus 16. Okay, so swap the x's and y's and flip it, so you get 1 over 2y minus 4. So we want it when y equals what? Well, I'm not really sure. It's actually when x equals 0. We've got y equals 2 minus root 0 plus 16. Y is 2 minus root 16, which is 4, which is minus 2. So we want it when y equals minus 2. So when y equals minus 2, the derivative would be 1 over 2 times minus 2 minus 4, which is minus 1/8. And that's the gradient on the inverse function. Because we got the gradient on the original, then we swap the x's and the y's, and then we have to flip it, and so we get dy and dx, which gives the gradient, and then you flip it. Okay, so that's the gradient, and then you need a particular point. So at x equals 0, well, this is in terms of y. So you've got to go back to your original equation, which is y is 2 minus root x plus 16, and put x equals 0 into there. and that will give you 2 minus root 16 is 4, which is minus 2. So all you've got to do in place of that y, you just have to put minus 2, and that's where you end up with minus 8.